today we will understand two lines of regression. We already did problems on two lines of regression, that is when we have two variables x and y given. Okay, now we have the second method when mean and standard deviation are given. When mean and standard deviation are given in the problem, you need to do this method. Okay, so again it is almost the same, but there's only a slight change, that is our regression line x on y. The regression line x on y is x minus x bar is equal to bxy y minus y bar. As you can see on the screen, our x bar remains the same. X bar is equal to summation x by n, y bar is summation y by n. The only change is bx and by. Remember, when you had two variables x and y, in the formula we had x and y. Similarly here, when mean and standard deviation is mentioned in the problem, our regression coefficient, remember this is the regression coefficient. In the exam he will ask you find the regression coefficient. That means you should understand that you have to find bx y and byx, that is the regression coefficient. Okay, so the regression coefficient formula will be bxy is equal to r into standard deviation x divided by standard deviation y. This is very important. Now many of them may have the doubt why r is there here. R is coefficient of correlation. Coefficient of correlation. So you should not get confused if in a regression problem anywhere he'll mention the term correlation. You should never get confused. R has a role in regression also. Okay, yeah, so that is the first part of it. Next we have regression line y on x, that is y minus y bar is equal to byx x minus x bar. Then our x bar and y bar is the same, and then byx is equal to r into standard deviation y divided by standard deviation x. It is so easy, the formula. Here it is x standard deviation x divided by standard deviation y, and here it is standard deviation y divided by standard deviation x. So please remember the formula. Once you remember the formula, doing the problem is very easy. Okay, yeah, now this is the format in which the method 2 problem will be asked. Okay, method 1, it is you have two series, x series and y series, and you do it. In method 2, like this the sum will be asked, or you may straight away get sentences. You need to formulate the table in order to make it easy. Okay, so let's see this question. Find two lines of regression. Okay, he's asking you to find the two lines of regression. So here it's understood you're going to find out y on x and x on y, or vice versa, whatever. Okay, so he's telling you need to find for capacity utilization and production. So these are the two variables that he is giving you. Okay, remember we have variables even in all the methods. We have variables for x series and y series. So here variables is capacity utilization and production. Okay, so same is given in the box. We have production and capacity utilization. So to make the problem easy for us, we will take production as x and capacity utilization as y. Let's take it like that to make it simple. Okay, yeah, so he says mean is so much, production mean is so much, production standard deviation is 10.5, then capacity utilization mean is 84.85, and capacity utilization standard deviation is 8.5. If you didn't understand, no problem, further I will be doing it. Okay, so he is given coefficient correlation r is equal to 0.62. Sometimes he is not going to tell you coefficient correlation r is equal to 0.62. He will directly give you coefficient correlation is equal to 0.23 or something like that. He will mention. He is not going to tell you that it is r. Okay, if you are lucky enough, he may mention r is equal to. Okay, so then now estimate production when capacity utilization is 70%. estimate capacity utilization when production is 30%. So these are the two things that we need to find out. Okay, so let's get into the problem. Let's understand how to do the problem. So first we are going to write what is given in the problem. Okay, mean production. Okay, mean production or production mean is 35.4. that means that is the x bar. You know always that x bar is the mean. Okay, then standard deviation of production is equal to 10.5. so that is the standard deviation x. Then capacity utilization mean is given as y bar. Okay, and then standard deviation of capacity utilization is given as 8.5. okay, now we are going to do all this. Now we are going to put all that in this formula. Okay, so let's do it. We have calculation of regression line x on y. So as you can see, the line x minus x bar is equal to b x y minus y bar. Okay, so then it's understood here we need to find out the regression coefficient first. So b x y is equal to r into standard deviation x divided by standard deviation y. Okay, so b x y is equal to the coefficient correlation, that is 0.62. you can see it here, it's given in the problem. R is equal to 0.62 0.62 into standard deviation x, that is 10.5 here, and standard deviation y, that is 8.5. okay, so then you're going to divide 10.5 with 8.5 in the coming step. So that is going to be 1.235. okay, so then bxy is equal to 0.62 into 1.235, that would be 0.7657. okay, so just to make it little simple, we will just round it off to 2 decimals. So you can take bxy is equal to 0.77 just for convenience. As you know, in statistics all values are approximate, it is not exact. So we will just round off this to 2 decimals. okay, so then now we got the regression coefficient value. Let's put this value in the equation. okay, so that is equation is x minus x bar is equal to bxy y minus y bar. So then x minus, what is x bar? X bar is 35.4. you should be careful when you are writing the values from one point to another point. Carelessness is costlier. okay, so 35.4, so x minus 35.4 is equal to 0.77, what we found out in the previous step, y minus 84.8. okay, so check the values. So x minus 35.4 is equal to 0.77 into y is equal to 0.77 y. okay, minus 0.77 into 84.8, that is around 65.296. okay, so x is equal to 0.77 y minus 65.296. that minus what is this side will come here, so that becomes plus 35.4. okay, so x is equal to 0.77 y. so if you simplify this, you get minus 29.896. so this is my first one, regression equation x on y. okay, so this is the first line that I found out, so let it be there. Next I am going to do calculation of regression line y on x. Calculation of regression line y on x. okay, so as you all know the formula, we have the formula y minus y bar is equal to byx x minus x bar. Okay, so here you need to find the regression coefficient byx, which is r, that is the coefficient correlation, into standard deviation y divided by standard deviation x. Okay, so byx is equal to 0.62 into 8.5 divided by 10.5. Okay, so byx is equal to 0.62 into 8.5 divided by 10.5 is 0.809. Okay, so now byx, be careful when you're writing these terms, don't get confused and write the same thing again, so you get 0.51. Okay, so I'm writing back my regression equation. Y minus y bar is equal to byx x minus x bar. Okay, so y minus 84.8 is equal to 0.50 x minus 35.4. Here you have some more values, but I rounded off to the nearest decimal. I am just taking two decimal values. Okay, so y minus 84.8 is equal to 0.50x minus 17.7. If you multiply 0.05 into 35.4, you're getting 17.7. Okay, so further we simplify. Y is equal to 0.50x minus 17.7 plus 84.8. This minus becomes plus. Okay, so you have y is equal to 0.50x plus 67.1. 84.80 is the biggest number which has positive sign, that's why we have plus 67.1. Okay, so now we got y on x also. Okay, now remember I told you we will take production as x and capacity utilization as y. Okay, so let's read the statement. Estimate production when capacity utilization is 70%. So let's write that here. Estimate production when capacity utilization is 70. Estimate production when capacity utilization is 70%. This is too difficult, you will feel actually. So what we'll do is we'll take it in the statistical term. Okay, so what did we say? We said production is x and we are saying capacity utilization is y. Okay, so we'll make it simple by writing it estimate x, that is find x when y is equal to 70%. Okay, which means find x when y is equal to 70%, means 70 divided by 100, which is 0.7. That means if I should put question mark on x, I should use the x equation. So whereas my x equation, here it is. So what is it? My x equation is x is equal to 0.77y minus 29.896. Okay, so then I have to find out y. No, so I have y here, I have to find out x. So x is equal to 0.77 into 0.7 minus 29.896. So x is equal to 0.539 minus 29.896. 896. So x is equal to minus 29.357. So you got the value. You got the value for x. Okay. Now similarly they asked us one more question. The second part of the question. Estimate capacity utilization when production is 30%. So I'll just write down that also. Estimate capacity utilization when production is 30%. Which means what is production? Production is x and capacity utilization is y. So I have to take it like find out y when x is equal to 30%. 30% means 30 divided by 100, which is 0.3. Okay, so then I have to take the y equation. What is my y equation? Y is equal to 0.50x plus 67.1. So y is equal to 0.50 into 0.3 plus 67.1. So y is equal to 0.15 plus 67.1. So y is equal to 67.2203. So that's the part of the question which is important. Kindly do. I am just giving you one practice problem also here. So kindly try to solve the practice problem. Find the most likely production corresponding to rainfall from the following data. Okay, so he is given coefficient of correlation 0.8, then rainfall production, then you have the average standard deviation. Average is 30, standard deviation is 5, and then you have the production average as 50 and the standard deviation as 10. Okay, so here also you can estimate production when rainfall is 12. This is first part of the question. The second part of the question, estimate rainfall when production is 22. Okay, I'll just take a minute and quickly tell you how to make it a bit easier. So you see we have average means mean. Okay, so average is the mean means you can take rainfall as x and production as y. Okay, so then you have this as x bar and this is y bar, and this you have a standard deviation x and this is standard deviation y. That is very simple. Then you can see this, you took production as y, so estimate y when x is equal to 12, and then estimate x when y is equal to 22. That means the first step y you need to find out when x is equal to 12, and the second question x you need to find out when y is equal to 22. Thank you. If you like my video, kindly like, share, subscribe. Bye.